the additional units of the variable input will produce more than the previous unit of variable input, but eventually will produce less. That is the sort of key idea. That you must get. And of course, that's completely understandable. I mean, if you don't get it, come to my house and I'll have you work in my garden and you'll get it very quickly. No, really, you will. Very quickly. You know, no problem. So this is it, right? This is the marginal product of labor. The claim is, in the short run, it always looks like this. Now this is stylized. In reality, it looks more like this. It actually looks kind of like, I don't know if I can draw it quite this way. In a lot of firms, the beginning part looks kind of like that. And then I'll just do this, like this. But then in the middle part would be even flatter than this. In the middle part, for example, a big auto plant, as you hire the initial workers, the productivity of the initial worker goes up a lot. So you might have like less than 50 workers, you have an increasing marginal product. Then between 50 and 500 workers, marginal product is virtually constant. And then when the plant is almost full, marginal product falls. Sorry, marginal product falls like this, something like this. This is the way it typically works. Okay. Now, somebody tell me a job where you saw this working like this. Have any of you worked in a factory? Oh. Okay. When I was like your age, one summer, I normally worked in the pipeline. The pipeline for about 2 months. They finished all the work and I didn't work for those 2 months. So I got a job working at night, welding, because I knew how to weld. I knew how to weld in the pipeline. So this was a huge factory, like this, a huge building. And in the building, there was about 50 welding machines, stations you might say, welders, acetylene torches, and all this stuff. The welders are electrically driven, so there's all these wires, right? So there are these 50 stages and like large, you know, like there might be a stage like this, it wouldn't be this big, it would be maybe this big, maybe like that, so you'd have a kind of table like this, and you'd have, you know, welding stuff in the vicinity. And then there'd be in between there'd be these broad aisles like this, right? So essentially what you did was you welded, it was kind of simple welding, like just flat welding, right? You made angle iron and stuff like that. So you get an order. So when the factory is not full, it's really easy. Now first of all, I don't know if you do any weld. If you weld, and you look at a weld, somebody welding close, it'll blister your eye. Very painful, super painful. It's like having a sanding there, I can't sleep. So you don't want that to happen. Now that normally doesn't happen if there's nobody around you. So generally you're just working away, you don't have to worry about that. You don't have to watch anybody else. But the stations are not, you know, the next person would be here and I would be over there. And then, you know, all the way around. So when there's like 50 people there, as you add people, you become kind of more productive because you can help each other out. Somebody might bring in their steel, they bring their steel and your steel. They might help you with something. So you're getting a little bit productive. But in the middle, you have like 50 people, you have like 100, you know, well, I would say, you have like 50 stations up to that point, maybe they're still getting more productive. But between 50 and 80, there's no change. At 80, it starts to fall off big time. Because you're starting, I can't move. You know, if I try to start welding, somebody else welds it near me and I get flashed conceivably. So I have to be really careful. When I try to bring my steel in, there's about 3 other guys bringing steel in. I trip over everybody else's wires. If there's 90 people, when the place is pretty full, it's really hard to be productive. As it turns out, it's really hard. Because you're tripping over everybody else. So there's an example. Now, your task this weekend is to figure out in your world an example. Figure it out, have it very clear, and never forget it. Because this is the story. Productivity of an additional worker goes up because capital is fixed initially because they can specialize. But at some point, the productivity of an additional worker goes down. We're just talking about the productivity of an additional worker. And of course, it has nothing to do with It has to do with the organization of all the workers. But it looks like the additional worker. So notice, if I hired only one worker, I would only get 10 units of cloth. If I hired a second worker, I get 30. So actually it looks like the second worker made me 20 extra units of cloth, when really it was the two of them. If I hired the third worker, I would get 60 units of cloth. And it looks like if I hired the third worker, I'd get 30 extra units of cloth. So that worker becomes more useful to me. If I hire him, I get 30 extra units of cloth, right? So this is the way it works. Now then, so there's that in general. Please remember that it's the secret, really, of the whole shape of marginal cost. Okay, now the second thing is, Marshall, by the way, understood all this junk. But Marshall's a really good mathematician, so he doesn't say marginal. He just uses calculus. He uses derivatives all the time, you know that. So, you know, when you read him, he understands all this stuff. He just doesn't explain it simply. He just uses calculus, usually in the footnotes. But he also understood, but a woman named Joni Robinson simplified all this in the 1930s to give us this presentation. So she noticed there's a relationship between the marginal product and the average product. Now it turns out, we're going to be really interested in the marginal product because it's going to determine the marginal cost to determine what the firm should produce to maximize profit. It's the only thing we need to know to figure out how to maximize profit. We don't actually need to know what the profit is. All we need to know is the marginal product to know the output that maximizes profit. And then we can figure out the maximum profit. And we figure that out from the average product. Okay? So I'm going to show you something pretty straightforward. So the average product, now you think about this. I'm marking exams. And it turns out by accident, say, the exams that I marked for this test went like this. The first person got 10, the second person got 20, the third person got 30, all the way up to the top person got 95. Everybody? And then that person then 90, 90, 90, in this shape. Everybody? Okay, now, what do you think the average product looks like? So the average product, if we were just going by one unit, the average, as we'll see on this diagram here, if we're just going by one unit, this is the total product is 11, the average product of one unit is 11, and the marginal product of one unit is 11, i.e. it's the product of one extra unit. In this case, suppose two people produce 40. The average product is 40 divided by 2, which is 20, and the marginal product is 40 minus 11, which is 29. They're not the same. Then 3 people produce 81. The average product is 81 divided by 3, the average product of each worker. But the marginal product is 41. Everybody, let's go to the diagram now. Here, as that marginal product goes up, as I mark my exam, supposing the first exam I mark is a 10, the average of the whole students at that point is 10, and the marginal product is 10, right? And the total product is 10, in this case, the total exam product. Okay, then I mark the next exam. The next exam is 20, everybody. The first exam was 10, the next exam was 20. The marginal exam is 20. What is the average mark? Everybody, 15, right? Then I mark the next exam, it's a 30. The total number of marks will be 60, but we don't care. The margin is 30. Does the average go up? If I mark the next exam, and the next exam is higher than the average, does the average go up? Yes. That's all we need to know. So what happens is this. Think about it. As I mark my exams, so long as the marginal product is going up, all the way, for example, to there, my average mark must be going up. All right, everybody? Now next. Now in this range here, I mean from here onward, notice, this is where my average is right now. The marginal exam is now falls from 95 to 90, but the average of the class is 70. The marginal exam of 90, does the average go up or down? It goes up. The margin is falling, but the average is going up. When will the average start going up? Why does the average go up? The average goes up not because the margin is rising and falling, but if the margin, the last exam, is greater than the average. Everybody? So then, this continues, and these are just very fundamental laws to say this point right here. At this point, the margin is equal to the average. Now when I go beyond this point, I want to know one thing. Does the average rise? Does the average fall? Why does it fall? Sorry?
Because the marginal
Yeah, because, as you can imagine with the exam case, suppose I get to the point where the class average is 75, and the last exam I marked was 75. The next exam is 70. It must be that the average goes up, right? If the margin is less than the average goes down. If the margin is above the average goes up. So it turns out these two things, abstractly, are related this way. That's what the average looks like. The margin cuts the average at the maximum of the average. Always and forever, right? This is the relationship between the output of a marginal worker and the output of an average worker for every possible production function. That's fairly normal, not some weird thing. I mean, that's like, really primitive. As I said, there's the case of rate you believe when there's only one rate. It's not interesting. It doesn't matter how many people you have, there's only one rate. So that you need to draw and understand. Okay? Now, that is our fundamental result right now. Now I'm going to use our fundamental result using marginal revenue and marginal cost. It turns out we can show, we're going to get to this later, but marginal revenue equals marginal cost maximizes the profit you get, right? You produce the output, we hire, the rule would be hire labor up to L, where marginal revenue equals marginal cost. Now what does this mean? What's the marginal cost of labor? It is the wage rate. To simplify it, right? What is the marginal revenue in this case? It's what is being produced. Okay? So it turns out in the labor case, it simplifies to this. You hire workers up to the point where the last worker you hire has a marginal product equal to the wage rate. Now let's just imagine we did it this way, okay? I'm paying you guys in wheat. This just simplifies the story. I don't have to go into dollars and stuff like that. You're gonna work on my farm. I'm gonna pay you in wheat. Everybody, I'm gonna pay you in wheat. So basically, I want to maximize the difference between the wheat that I pay you and the wheat that you produce. Everybody? Now, if you try to work this out on your own, you could spend a million years trying to figure out what output maximizes the difference between the total amount spent given out in wheat and the total amount produced in wheat. But our rule is simple, just like we learned from the wage rate if you're deciding how many hours to work. Because what we do is this. Our rule says, supposing this is the wage rate right here. This is WO. We simply produce, and this is a fundamental idea, it's actually not in my notes, but it's the same idea of everything we're going to do in the rest of the notes. If this is the wage rate like this, and I want everybody in this, to look at this and tell me according to the rule. You don't necessarily have to understand the rule right now. How many workers do I hire? Do I hire this amount of workers? 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 Or do I hire this amount of workers? What does the rule tell me I hire? How many workers do I hire according to the rule? This is fairly straightforward. The rule says I hire the number of workers up to the point where the marginal product, the product of the last worker, exactly equals the wage rate. So how many workers do I hire? People, come on. Yeah, tell me. Were you gonna tell me? Were you gonna tell me? Huh? Okay, go on.
From the marginal product equals the wage rate.
Oh yeah, sorry, I should have, I suppose, for me, I see it what it is, but I should have maybe put in for you guys this. This one here is the marginal product of labor, perhaps you forgot. This will be the charitable interpretation, but fair enough. This is the average product of labor, right? Okay, now, the zoner says, you hire this amount of workers. Now watch carefully, because our rule, as I showed you with that wage rate for the hours that you work in a week, our rule is ridiculously simple. But you wouldn't find it by yourself. You're someone like Marshall, figure out after many, many years. Some people would say, why don't we hire this many workers? Notice here, why don't we hire up to the point where the last worker, the average output of the worker is equal to the wage rate? Everybody? Okay, let's do that. Then let's figure out how much grain we pay out in this case. Watch. Each worker gets this amount of grain, and up to this point, that's the total amount of grain that we pay out. There's the wage rate times the number of workers up to the point where the last worker, the average product is exactly equal to the wage rate. Now tell me what the profit is for this person. What is the profit for this person? How much profit is there right now? Yeah.
Everything under the gravel excluding that rate.
Which parabola? Which parabola?
The tall.
Yeah, in terms of, it would, the way it's drawn is a little bit odd. It would, strictly would be, if this is properly drawn, mathematically drawn, like an equation, L's proportion is correct. You could take one way of getting the total product of all these workers would be to add up the product of each worker, so all the margin products, right? And if you did that, you would have, notice, these workers produce more than the average product, but these workers here produce less than the average product, and these workers produce less than the average product. So you have this triangle under, and this area over. And it turns out it's misrepresented because it turns out those two would be exactly equal. How do you know? Because the average product of the worker tells you how much is produced by the workers, right? That area there is the total output. The average product of one worker times all the workers is the total product. Even though your idea is correct, you're absolutely right. But it's misrepresented here by the way I drew it. It's not perfect drawing. But it turns out you cut to the chase. To find out the total product, you don't screw around with adding up all the marginal products. You look at the average product. So it turns out the area there is the total product, and it's also the total payment to the workers. There is no net profit at that output. None? Okay, good. So then that's not going to work. And people would say, well, here's another obvious one. Let's say, wait a minute. Let's produce here, because look here. This is where we should produce, because notice, the last worker produces that much more for us. Notice? That's the greatest extra amount produced by this worker. You pay this worker this amount, and they pay you this amount. That's where we should produce. Or you could say, this is where we should produce. But in fact, those are wrong, as I'm going to show you. It turns out this is where we should produce. Now watch, I'm going to tell you what the total product is, the total profit is. If you produce here, and you're going to use the trick I told you about, this is marginal product. This is the total output, the total payment to the workers in grain. Now I want to know the total output of the workers. How can I find the total output of the workers? What's the simplest way? I already showed you that. What's the simplest way? Yeah, go ahead, Eric. Yeah, you look at the average product. One worker produces on average this, all workers produce that. So it turns out the total product is, in this case, this. There's the total product, and if I can get this one, this thing here. Okay, there's the profit right there. See it? Okay, now, the rule is, when we prove the rule in general, that whenever you produce the output or have a number of workers where the payment for the last unit is exactly equal to what you get from the last unit, i.e. marginal revenue is marginal cost, you always maximize profit. Now, it turns out you should say here, the rule really applies greater than, so I'm going to show you, now notice everybody, weirdly, the productivity of additional workers is falling. So that doesn't seem to make huge sense. Let's try this one. What if the wage rate was this? Oh, I should also do this another way. Let me just do this one other way. We'll come to this again. How do I know this adds to profit? Because notice now, everybody. Notice, I'll just write it like this. If I stop here, producing, I would give up, not gain, this extra profit on the next worker, and this extra profit on the next worker. Everybody? This, I want to maximize the difference between what I pay out and what I get produced. So if I stop there, I would miss the fact that the next worker would produce more than I pay them. So if I'm just sitting here, I'm going to talk to Bill, for example, and say to Bill, we did before, hey Bill, here's the deal. You've got money there, like you've got 50 cents there, and I'm just going to keep giving you $1.